This video is over projectile motion. You will need a graphing calculator, so make sure that you do open up to one on your computer or your phone, or whatever. If you actually have a graphing calculator, that would be great. But you will need that for this, okay? So it says a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h equals negative 16t squared plus 90t gives the height h of the ball after t seconds. Find the maximum height of the ball. Okay, so they gave you a little picture up here. So if you are kicking, and I know it's not exactly like this, but if you're kicking a ball up in the air and you're trying to find the maximum height, you're trying to find the vertex up here at the top is what you're looking for. So the maximum height is the y value of the vertex is what you're looking for. Okay, so you could do this by hand. It's easier if you just do it on the graphing calculator. All you have to do is type this equation in on your y equals and then go to your graph and just move, and you can hit trace, and you want to move that little dot. You want to keep moving that dot up your little parabola here until you get to the very top point to figure out what that's going to be. Okay, to do it by hand, you would have to use your axis of symmetry formula, which is x equals negative b divided by 2a. So x equals negative b divided by 2a. Okay, so in this case, we're talking about h and t, so that would be t equals our, it would be negative, our b is 90, divided by 2 times our a is negative 16. Okay, so if you solve that, that's going to be around 2.81. Okay, so then if we take that and we plug it into our original equation right here and plug it in for the t's and find out what our h is going to be, that will tell you what the maximum height is, because remember, our axis of symmetry is the imaginary vertical line that goes through our vertex. So that just found our x value of the vertex. So we need to know what our y value is so we can find our maximum height. So you can say h equals negative 16, and then where that t is, we're going to plug in 2.81 squared plus 90 times 2.81. If you solve that, that's going to give you your height, which is around 126.56. And you should get the same answer if you do it on the graph and find what the maximum height is, so what our y value is up here at the vertex. Okay, so it's going to be 126.56 feet. The second question is, it says, how many seconds will it take for the ball to reach the ground? So we're looking for this point right here. So our x-axis is right here. We're looking to see when that ball hits the ground. So you want the positive x-intercept of that. So one way that you can do it is you can factor this. That's how you can do it algebraically. But if you're looking at your calculator, you can just see, you can do trace and run that point down to see where it's going to hit right here. Okay, so if we were to factor it, then you would just take this equation, negative 16t squared plus 90t, set it equal to 0. Okay, so what's our greatest common factor here? Well, we have, we can take a negative 2 out of these, and we can take a t out. So we're going to factor out a negative 2t. So negative 16t squared divided by negative 2t is 8t. 90t divided by negative 2t is negative 45. Then we're going to set these equal to 0 and solve. So we have negative 2t equals 0, which you get, divide both sides by negative 2, you get t equals 0. You have 8t minus 45 equals 0. So you want to add 45 over. So we have 8t equals 45. Then we're going to divide both sides by 8. And t is going to be around 5.625. Okay, so we have 0 and we have 5.625. Well, it originally started at 0 because we're kicking the ball let's say that this right here is our y-axis. We're starting at 0 and then we're kicking the ball up and we are looking to see when it hits the ground over here. So our time it takes to hit the ground is 5.625 seconds. Okay, so 5.625 seconds is going to be our answer on that. Okay, number 2, it says an apple is launched directly upward at 64 feet per second from an 80-foot tall platform. The equation for this apple's height h at time t seconds after the launch is h equals negative 16t squared plus 64t plus 80. Find the maximum height of the apple. Okay, same thing as what we just did up here, and you can also type this in on your y equals and go to your graph to find it. Okay, so if we were finding it by hand, we would say t equals negative 64 divided by 2 times negative 16. Okay, and that is going to be 2 is our x value. So then to find our y value, we just take that 2 and we plug it back in right here. So h equals negative 16 times 2 squared plus 64 times 2 plus 80. Type that in, solve it, and you get 144. So it's going to be 144 feet. Then it says, how many seconds will it take for the apple to reach the ground? Okay, so we're going to factor this. So negative 16t squared plus 64t plus 80. Okay, so can we take a negative 16? Can we factor negative 16 out of this? Yes, so it becomes negative 16. Negative 16t squared divided by negative 16 is t squared. 64t divided by negative 16 is negative 4t. 80 divided by negative 16 is negative 5. So then you want to factor this. What multiplies to give you negative 5 and adds to give you negative 4 is negative 5 and 1. So we have negative 16. We have t minus 5. T plus 1 equals 0. So then setting each of them equal to 0 to solve. Negative 16 does not equal 0, so it cancels. T minus 5 equals 0, that's going to be a positive 5. T plus 1 equals 0, that's going to be a negative 1. Can you have a negative time? No, so it doesn't work. So the only time that works here is 5. So it's going to be 5 seconds is going to be your answer. Okay, number 3. In science class, the students were asked to create a container to hold an egg. They would then drop this container from a window that is 25 feet above the ground. If the equation of the container's pathway can be modeled by the equation h equals negative 16t squared plus 25, how long will it take the container to reach the ground? So first we want to find the maximum height of the container. Okay, same thing. So we're doing they don't have a b term here, so our b is going to be 0. So it's t equals negative 0 divided by 2 times negative 16. Okay, that means it's going to be 0. So to find our height, we have h equals negative 16 times 0 squared plus 25. That's going to equal 25. So 25 feet is our maximum height. How many seconds will it take for the container to reach the ground? So negative 16 t squared plus 25 equals 0. So we want to solve this, okay? So figure out which way is the best way to solve it, probably using the square root method. So subtract 25 over, so we have negative 16t squared equals negative 25. Divide by negative 16, so we have t squared equals 25 over 16. Take the square root of both sides, so t equals 5 over 4, okay, which is the same thing as 1.25. So it's going to take, and technically this is a plus or minus, right, but we can't have a negative amount of time, so we're only looking at the positive here. So it's going to take 1.25 seconds. Okay, and guys, those of you who haven't learned some of these methods, remember you can always do this on the calculator using your graph. Okay, all right, flip over to the other side. A penny is dropped off the Empire State Building, which is 1,250 feet tall, if the penny's pathway can be modeled by the equation h equals negative 16t squared plus 1,250, how long would it take the penny to strike a 6-foot tall person? All right, so we have the Empire State Building. A penny is dropped off. We have a person down here. This person is 6 feet tall. Okay, the Empire State Building is 1,250 feet tall. Okay, so we are trying to find when this is going to hit a 6-foot tall person. So you can say negative 16t squared plus 1,250, and it's going to equal 6. Okay, because we're looking to see when it's going to hit when our y value is 6. Okay, so what we need to do here to solve this, you can subtract 1,250 over. So we have negative 16t squared equals 6 minus 1,250 is negative 1,244. Divide both sides by negative 16. So we have t squared equals 77.75. Take the square root of both sides, and you're going to get around plus or minus 8.82. And you only use the positive, so 8.82 seconds. So if you're looking at your graph, or you can go to your table, you're looking to see when your y value is 6, what is the x value? That's what you're looking for. So when your y value is 6, what's the x value? Okay, number 5. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height h at time t seconds after launch is h equals negative 16t squared plus 80t. How long will it take the fireworks to reach the ground? So we're looking to see when the so you shoot the firework up, you're looking to see when it hits the ground. Okay, so when it's at 0, so when our height is at 0, so negative 16t squared plus 80t equals 0. Okay, what can we factor out of this? Can we take a 16 out of 80? Yes. So we're going to factor out a negative 16, and we can take a t out of both of those. So negative 16t squared divided by negative 16t is t. 80t divided by negative 16t is negative 5. Then we're going to set both of those equal to 0 and solve. Okay, so on this one, you're dividing by 0 divided by negative 16 is just 0. So we have t equals 0, which is a starting point. The other one, you want to add 5 over, so we have t equals 5. So it's going to take 5 seconds for it to hit the ground. Number 6, the Apollo's Chariot, a roller coaster at Busch Gardens, moves at 110 feet per second. The equation of the ride can be represented by the equation h equals negative 16t squared plus 101t plus 10. What is the maximum height reached by this ride? So this time we are looking for our y value at the vertex. We're looking for our maximum height, like what we did on the A answers right there. Okay, so we're going to take the axis of symmetry formula. So we have t equals negative b, which is 101, divided by 2 times our a, which is negative 16. Okay, and when we solve that, it's going to equal 3.16, somewhere around there. Then we're going to take that, we're going to plug it back in here to find out what our maximum height is going to be. So h equals negative 16 times 3.16 squared plus 101 times 3.16 plus 10. And that's going to be around 169.39 feet. Okay. Number 7, it says Eva is jumping on a trampoline. Her height h at time t can be modeled by the equation h equals negative 16t squared plus 20t plus 6. Would Eva reach a height of 14 feet? Okay, so does she ever get to a height of 14 feet? Well, to figure that out, we need to figure out what her maximum height is going to be when she's jumping on the trampoline. So we're trying to find this point right here. So we can do that the same way we did this one. So you can say t equals negative 20 divided by 2 times negative 16 which is going to be 0.625. Then we're going to take that and plug it in here. So h equals negative 16 times 0.625 squared plus 20 times 0.625 plus 6. And that's going to be around 12.25. So her maximum height that she gets to is 12.25. So does she ever reach 14 feet? No, she does not. And you can say max is 12.25 feet. Okay, and then this last one, an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. The equation of the baseball pathway can be modeled by h equals negative 0.8 t squared plus 10t plus 2. The same experiment is done on Earth, in which the pathway is modeled by the equation h equals negative 4.9 t squared plus 10t plus 2. How much longer would the ball stay in the air on the moon compared to on the Earth? Okay. We are trying to find the difference between the time that it hits the ground for the moon and the Earth. So we're trying to find the difference there. So first, it's not going to be easy to factor this because we have decimals here. So we're going to do the quadratic formula on both of them and then compare the two together. Okay, so remember the quadratic formula, we did that on the last note sheet. That's that negative b plus or minus b, the square root of b squared minus 4 times ac divided by 2a. Okay, here, I'll write that over here. So x equals negative b plus or minus the square root b squared minus 4 ac over 2a. So that's what we are using on both of these. So we have negative 10 plus or minus the square root 10 squared minus 4 times our a, which is negative 0.8, times 2, which is our c, over 2 times our a, which is negative 0.8. Okay, so we have negative 10 plus or minus the square root. 10 squared is 100. Negative 4 times negative 0.8 times 2, well, actually, let's go ahead and do this. We have 100. You can go ahead and solve all of that together right there, and that's going to equal 106. And then down here, this is going to equal negative 1.6. Okay. Then if you take the square root of, if you go ahead and type that in the calculator, so you have negative 10 plus the square root of 106 divided by negative 1.6, you're going to get 12.7, and then negative 10 minus the square root of 106 divided by negative 1.6, you're going to get negative 0.2. So our two answers here are negative 0.2 and 12.70. You can't have a negative time. So it's going to be this one right here. Okay, so we're going to compare that to our answers on the other side. So we have negative 10 plus or minus the square root 10 squared minus 4 times our a is negative 4.9. and our c is 2 over 2 times negative 4.9. Okay, so we have negative 10 plus or minus the square root. When you solve all of that underneath there, you're going to have 139.2 over 2 times negative 4.9 is negative 9.8. Okay, so our two answers here, negative 10 plus the square root of 139.2 divided by negative 9.8, you have, and then negative 10 minus that, you're going to end up getting negative, what is that, negative 0.18 and 2.22. Okay, the negative is not going to work, so we have 2.22. So now they've asked us to compare these two. It says how much longer will it stay in the air? Okay, so you just take the difference. So you have 12.70 minus 2.22, and you're going to get 10.48. So it's going to be 10.48 seconds. Okay, another way that you could have done that is you could have typed this in on your y equals and found out, looking on your graph, where does it hit? And then same thing on this one, where does it hit? And then subtract your answers, because you should get this, and then you're going to subtract them. Okay, so remember, all of these you can do on your graphing calculator as well, but I also showed you how to do them algebraically. So this is projectile motion.